Welcome. Welcome to Module 2. Now that we have a high level understanding of the project's architecture, we are going to zoom into the first layer, the user interface. In this section, we will explore how we built the entire visual part of the application using Jetpack Compose, Google's modern toolkit for building native Android UIs. Let's look at the agenda. We will cover the Jetpack Compose at high level. Then we'll cover building our main screen, which is SearchActivity.kt file. Then we will understand how did we connect this UI to the logical layer or MVVM. And then we will do practice of making live changes to the code of this UI. Okay, so before we look at our code, it's crucial to understand the fundamental shift that Jetpack Compose represents. The old way of building UIs on Android was imperative. You would write a list of step by step instructions. For example, find this text box, now change its text. Find this button, now disable it. This was the old way. This often led to complex code that was hard to manage. Compose is declarative. Instead of giving steps, you simply describe what the UI should look like for a given state. So you say, if the state is loading, show a progress bar. Or if the state has data, show a list of data. That's it. Compose handles the rest. This simple idea drastically reduces bugs and makes our code much cleaner. Now we'll look in the next step the building blocks of composable function of Jetpack. So let's look at the building blocks of our application, the composable functions. The fundamental building blocks of a compose UI are functions marked with the at the rate composable annotations, which you can see on the left hand side of our screen. These are just regular Kotlin functions, but they have a superpower. They can describe a piece of UI. For example, in this example, the greeting function describes a simple text element. We can call other composable like text, button, or column inside our own composables to build a complex screen from these small reusable pieces. Everything in our application or on the screen which you see is a composable function. Now on the right hand side, if you see, this is a code snippet from our SearchActivity.kt. What it is doing in this code is it's first checking for the status of user, and while it is doing, which is user status.loading, it gives a circular progress indicator. That's the first code after when. The second code is user status.trial and user status.subscribed. In any one of these cases, the application goes to the main search UI. The user will reach that page. If the user status is expired, which is the next line of code, it will take the user to paywall screen to subscribe. After this, we will look in detail of how to use these composable functions. Okay, so now let's understand how does the application remember the state of data or field using compose. Before that, let's understand what are we trying to create here. Our main goal is to create a reactive UI, which means we want our screen to automatically update itself whenever the underlying data changes, without us having to manually write code to find and update each specific UI element when the data changes. To achieve this, we need a system that does three things. First, holds the data that can change. We call it the state. Second, observes the data for any changes. So this is the observable part of the application or the UI. And third, keeps that data alive even when the UI is being redrawn. So this is called the remember part of the code and the UI. So if we describe the UI, how does it change and be reactive? The answer is state. State is any value that can change over time in the UI. In Compose, we use the term mutable state of to create an observable state holder. So if you see in the code here, var text by remember, and then you have the bracket and you have something inside it, which is mutable state of, and this is string or text. So it will remember the string or the text, the initial state of this text. What is a mutable state? A mutable state is simply any piece of data which can change. So let's Think of it as the live information that our UI is displaying. So this is called a mutable state, anything which can change on that screen. For example, the text a user is typing into a search bar, the on and off position of a switch on your UI, or the current number in a counter are all pieces of mutable state. So if your UI is displaying some numbers and it keeps changing, that is also a mutable state. These things are not fixed, they are expected to be modified by user action or any triggered events. What is observable state holder? An observable state holder is a special wrapper or container that holds your mutable state. The key word is observable, which means it can be watched or it can be subscribed to. In Compose, this wrapper is created using mutable state of. You can check the code. Its job isn't just to hold the value, but to notify anyone who is watching whenever the value inside it changes. Think of it like a newspaper delivery subscription. So mutable state, the latest news or the latest data or the article. Observable state holder, the delivery service. Your UI or your composable is the subscriber. You don't have to constantly check the newsstand to see if there is a news story. The delivery service, the state holder, automatically sends the new paper, article, or data to you as soon as it is published. More like how you have notification. When Compose sees this notification, it knows that any part of the UI that depends on this specific piece of state needs to be redrawn or changed accordingly to reflect this new information. This is the foundation of a reactive UI. The interface reacts automatically to changes in this underlying data. When we wrap it with remember, we are telling Compose to keep this value in memory even when the UI is being changed. In this example, the text variable holds the current value of your text field. When the user types on value change, callback is triggered. We update the text variable, and Compose is smart enough to see that the state has changed and automatically redraws just the part of the screen that depends on it. This is the magic of reactive UI. So now we know this mutable state is simply the data that needs to change. The wrapper or the mutable state of. This is the most important piece when we write mutable state of under bracket initial text or string. We are not just storing the string's initial text. We are putting it inside a special wrapper or container. This wrapper does one critical job. It turns a normal piece of data into observable state holder. Think of it like putting your data into a magic box with an alarm system. So holding the box holds your value. Observing if the value inside the box ever changes, the alarm goes off. Remembering the status, the remember function. So UI components in Compose can be redrawn many times for many reasons. The remember function solves this. It tells Compose, create this state holder once and then keep it in memory for this specific component across redraws. It gives your state a memory, ensuring the user input isn't lost every time the screen updates. In short, remember ensures the same magic box is used for a component no matter how many times it is redrawn. So now let's look at the build of our main screen SearchActivity.kt file. Search activity file has 5 main functions defined in it. So you can look at it here. Search activity, the app's entry point. Then you have the open file, which is a separate utility function. The app content, which we have already looked at before, 2 sections before. The main search UI, the core search interface, and the paywall screen. So what is search activity, entry point, and payment handler? If you look at the first code or the first line of the code, which is class search activity and component activity and payment result with data listener, this is the main screen of the application. It acts as a central controller for the user interface and the payment process. It has the initialization in the on create function, which is inside it, and you can't see it here. The activity sets up the app's user interface using set content. It also initializes a payment manager, a class, again not shown in this file, a class which handles the logic for starting a Razor Pay payments. Then it has a payment listener, which is payment results with data listener. The activity implements payment result with data listener, which means it is designed to listen for results from the Razor Pay payment SDK. Within that, it has on payment success function. This function is automatically called by the Razor Pay SDK when the payment is completed successfully. It then delegates the handling of this success to the payment manager. Similarly, it also has an on payment error if the payment fails. This is called if the payment fails for any reason, delegating the error handling again to the payment manager. In short, if the payment is successful, it will show a result payment successful. If it is not, it will ask to retry. Second one, if you see, which is private fun, open file, context file, URI. This is a utility function, and it simply is a helper function separate from the UI composable. What it is required is to read files in Android system. So its functionality is that it creates an Android intent with the action underscore view function. This is a standard way to ask the Android operating system to open a file. The OS then finds a suitable app installed on the phone, like a PDF viewer or a text editor or XLS, to handle the request based on the file type. It also has an error block or error handling block. It includes a try catch block to show a toast message, a small pop up if no app is available to open the given file type. A third one, we have already done it, the app content, where we saw the conditional rendering. If the status is loading, it shows a simple loading spinner. If the user is in trial or subscribe, it takes it to the main search interface. And if it is expired, then it will take you to the paywall screen. The next one, which is the main or the heaviest part of this code, is the main search UI, which is the core search interface. This is a composable function which defines the entire user interface for the file searching functionality. It is designed according to the logical layer or the model view model architecture. The layout, the UI layout, it builds the visual elements of the screen, including, so it has a UI layout. It builds the top bar with the app title and a clickable link to select folders. Then it has two text fields, one for the main search query and other to filter the result. Then it has a search button to start the process and a scrolling list to display search result. The scrolling list is a lazy column, which will again go in detail later. Then it also has a state management where it observes the data from the view model. So from the logical layer, if the data comes changes, it observes that change. And then when this data changes in the view model, the UI automatically updates. So if based on the activity in the logical layer, if the state of the data has changed, the UI will automatically make changes to accommodate the output. Similarly, it also sends events to the view model. So when you're doing an entry into the application, it will send notifications to the logical layer. It also handles user interactions. When the user clicks on a search result item, it calls the open file helper function to open the file using appropriate application on the device. Last one is the at the rate composable fun paywall screen on start payment, blah blah blah. So this is a simple composable screen shown when the user needs to pay to continue using the application. The purpose, of course, its function is to inform the user that trial had expired, or if you don't want ads, go and subscribe. And it has an action button, which is to allow it to subscribe. And when the button is clicked, it executes the on start payment function, which is passed down from the search activity to trigger the payment manager to launch payment flow. Next, we will see or deep dive into SearchActivity.kt code snippets, some of them. Also, we will understand how to build the jet compose codes. What is the syntax of it? Okay, so now let's look at our actual code structure in SearchActivity.kt. The main UI is built inside the main search UI composable function. In that fun main search UI, you can see the scaffold, which is the root of our screen. This is a standard material design layout component that gives us slots for common UI elements like a top bar, a floating action button, and the main content area. Inside this scaffold, we place a top app bar for our title and the select folders link. The main content is a column which arranges all our other UI elements vertically, one after the other. So that's the second part of the bottom part of the screen. Inside this scaffold, the code outlines a modern Android application, which is our Find My File, built using Kotlin and Jetpack Compose. The primary function is to search for text within the files on a user's device. And hence, the app also includes a subscription based payment. Handling user input is straightforward. Our outlined text field takes the current search query as its value. When the user types its own value, change lambda is called, which in turn calls our view model to update the state. All of this we have covered in the previous section, where we informed that the UI does the only work this UI will do is to collect to monitor the change. And once the changes are made in the state, it will trigger a notification to the logical layer. Similarly, our button has an on click lambda. When the user taps on it, we call the perform search and rank function on our view model, which is the logical layer. So you will notice how the UI's job is simply to report events. It does not actually does any logical work or doesn't do any search work. These work will be done in the next layer, which we'll cover in the next module. Then in the next session or section, we will go through lazy column. How is the output being shown using lazy column? Okay, so let's look at how to display our search result using lazy column. In Compose, lazy column is equivalent to recycler view. The keyword here is lazy. If you search and it returned 1,000 results, a regular column would try to create all 1,000 UI element at once, and this will cause the application to crash. A lazy column is much more efficient. It only creates and renders the items that are currently visible on the screen, recycling them as the user scrolls up or down. This ensures our app remains smooth and performant. Even with huge number of results, we are able to manage our application without making it crash. So in simple, if I have to go through the code here, so what you see on the top is lazy column. This is the start, which starts a vertically scrolling list. It is lazy because it is only rendering the required items currently visible on the screen, which is very efficient for managing long lists. Then you see the modifier equal to modifier dot fill max size. This makes the list expand to fill all available screen space. This is the use of this particular line of code. The next line, if you see, is vertical arrangement equal to arrangement dot spaced by 8.dp. This adds 8 dp of vertical space between each item in the list, more like formatting. Then you have items equal to results, and results, and then arrow. This is a loop. For every result in your list of search, it will create the UI defined inside the brackets. Next, you have column. This creates a vertical container for the content of a single list item. The title and the file path is considered as a single list item here. Then you have dot fill max width. This makes the item's container stretch to the full width of the screen. Then you have dot clickable. This makes the entire item tappable. So the single item that we had defined in the column, or if you remember in items equal to results, that is being made clickable here. So when you click on the output, the the code inside the bracket runs and you are able to open the file. So open file, this is the action performed on click. It calls a function to open the file corresponding to the specific search result. And if you remember, this open file is based on the code which was given 2 sessions before, where we discussed how it uses Android's inbuilt feature to open the file. Then you have dot padding, again vertical padding of 8.dp. So add some. empty space above and below the content inside the item. Then you have text equal to result dot title, so displays the title of the search result. And then you have text equal to result dot URI string, so it will give the URL or the URI of the file. And then you have the horizontal divider. This draws a thin horizontal line at the bottom of the item to visually separate it from the next item. So I hope this clarifies the whole code. In next, we are going to learn about connecting the UI to the logical layer. Okay, so we have come to the most important concept in this model, which is how to connect our UI to the application's brain, which is main view model. The main view model, which contains the view model, exposes its data using a special type called state flow. In our UI, we use the collect as state function to listen to this flow. This creates a subscription. So whenever a new data in the view model is generated or the data changes, the state changes. For example, when the search results are ready, the state flow emits the new list. Now collect as state in the UI will receive this new data or the change and trigger a automatic recomposition using compose to redraw the lazy column, which is our display function. This clean one-way data flow from the view model to the UI is the core of this architecture and is what makes our app robust. Now we are going to do a small code change as a lab exercise in the next slide. Okay, so we have come to the end of this session. So let's do minor change to one of the codes and see how it can be done. So your task is to add a clear button to the main search text field. So for that, you have to modify the code, which is below. And on the right hand side below, you can see how the text field or the search field should look. So you have to modify the outline text field in main search UI, which is there. It has a parameter called trailing icon, which you have to add. Then you also need to add an icon button inside the trailing icon slot. Inside the icon button, place an icon using icons.default.clear. So use this, add the logic. The on click for your icon button should call the on search query changed function in the view model, passing it an empty string. And then add a condition. The clear button should only appear when the search text field is not empty. You will need to wrap your icon button in a simple if statement. So this lab gives you a chance to learn and also use the experience. Good luck. I'll give you 20 seconds. Think about it, and then I'll show you the code. Okay, so let's look at the code. So here's how it works, broken down by each line. So trailing icon equal to, so you have to look at the code after modifier equal to modifier. Till there, the code is the same. Then we have added the trailing icon parameter. So this is a parameter of outline text field that lets you define a composable to place at the end of the field. Inside that, if you see if query dot is not empty, this is a logical condition. This is a if condition. The code inside this block will only run when the search query variable contains text. This ensures the clear X button only appears when there is something to clear. And then after this, you have the icon. So first you define the logic, which is if query, and what should happen when you run the if query, and then you define the icon itself. So icon button on click equal to this creates a clickable button designed specifically for holding the icon. The on click part defines what happens when the user taps the button. In this case, it calls view model on search query changed and empty string inside, passing an empty string to instantly clear the search field's text. So basically, when you click the button, when the conditions are fulfilled, it will restore the original state, which is an empty state in the search box. And below that, if you see, it is icon, image vector, and content description. So content description, an additional feature which I added, but icon image vector equal to icons.default.clear is basically it specifies which icon to display, which in this case is the default icon for clearing, which is X symbol. Now, content description equal to clear search is simply it will read out the X button for the users who wants the screen reader ability with the application. So it will announce clear search button so they know what the button does. Okay. So with this, we have come to the end of the session. We will summarize what we have discussed and then we will discuss about module 3. Okay, so let's summarize what we have learned today. We discussed the introduction to Jetpack Compose. Then we discussed declarative versus imperative UI, how they are different. We learned about composable functions, how to use it as the basic building blocks for creating UI. Then we talked about state management, how to use remember and mutable state of to create and manage states. Then we talked about building screens. We walked through the code for SearchActivity.kt. We understood scaffold, top app bar, column, button, how to structure the screen. We talked about lazy column, how to efficiently list all the outputs without crashing our application. Then we discussed about UI to logic connection, how to use collect as state as a subscriber to the state flow in the logical layer, and using that, how to observe data and make changes in the UI. And then we did a small practical lab. And now we are going to look at what we're going to cover in the next module. So, in the next module, we will talk about the logical layer, the core logic of this application. So, we will discuss about why background processing is crucial, how does it help in the architecture. Then we will talk about how to access securely the user files, maintaining the privacy. Then we will deep dive into the file indexer worker, which is the core code for the logical layer. Then what third party libraries did we use, how to integrate it in your code. Then we will talk about the on device AI model. And then we will again do a small practice lab. So, again, thank you for joining. Please share this session with your friends or your relatives who want to learn about Android application development. Thank you.